fraction. What do you mean a fraction? And your person neighbor's going to say, that's 22. Yeah, no, that's 22 over 1. Because you have to think like that. Okay? Good. Good. Here. Automatically. Somebody's going to take and try to divide by 10. Well, that's reducing by 10. Right? Now, you can handle it even better, can't you? Okay? Oh, what? 1, 10. You should be able to do that. Gotta do that. Take any fraction to a decimal. That's what we did. Okay? And that shouldn't take a whole minute. And that's where you're going to lose your time. Okay? Boom. Done. What have we done? Eliminated what? Zeros. What do zeros do? Zeros reduced by 10. Here we reduced by what? 100. Just like that. Boom. Knocked it down 100 times. Can I do that?
No.
No. It's not proportionate. Correct? You've changed the proportion. Don't believe me? This is 1. This is what? You made a what error? Okay? You give the person this instead of this. That's how we killed. That's how that nurse killed. Remember? Yeah, remember? Yeah. Because, it's you changed the proportion. They're not proportionate. Just that quickly. And then you go ahead and give it. Give the written instructions. 1 gram is on the label. In directions to be taken. They go ahead and take it. And sayonara. Okay? Good. Everybody can reduce a ratio to its lowest term, if you had to. Done? Done. Oh, no. Done? Yes? How long did that take?
For you.
No. I want you to get that way.
But you didn't do this big number then.
Okay. But you understand. And your author does all of these nice little things. Now take this, and then she'll give you the percent and say, well, go get the fraction. Right? Just be able to be fluid. And this is the time for you to practice, because we're going to go on to some other things having to deal with real medicine. Real health stuff. Come on, let's get to the needles. Yeah? Come on. Yes.
Professor, I'm okay with the way you're explaining, but if I'm to ask you, instead of writing 3 over 12, for example, go not in the useful aspect for mine. Can one write 1:12 also?
Mm-hmm.
1 is to, if you eliminate it, 1 is to 4, I mean.
Yeah, we took it 1 to 4 because we divided both by 3.
Like that is 1.
1 is to 4. Yeah, now what she was saying is 3 is to 12 what 1 is to 4. Because they're proportionate. Yeah, see, that's language. She does a nice job, and I'm glad you did that, because she was trying to tell you how to say that these two are proportionate. Now, one of the things she says is don't erase and eliminate your audit. Don't do that, because if you make a mistake, we can tell where you made it, and they can correct it right away. Don't go change this and replace it. You know what I'm saying? In your order and your instructions, show it. Because if you got down here and you ended up with 2.5, for instance, you look, you can see what happened. No, because 3 to 12 is the same as what? 25%. It is not 2.5%. Now, let's suppose that it ain't right. You just wanted to know where you went wrong. Leave your audit. Don't sit there, change this to this, because the original instruction is what? 3 parts drug to 12 parts solution, for instance. And what they want you to start doing, and we'll start doing that later, is literally putting the medical subscript. 3 to what? 3 parts of what? To what? For instance, 3 parts drug to 3 parts solution. 3 females to 12 males. Who's in the better situation? Depends. Supply, demand? Depends. Okay, next. Good. I have your attention now. No, absolutely. Okay, that's it. That particular chapter is history. This person's going into there. What I'd like for you to do is go through 1 through parts of 3, and that part of 3, and see if you have any questions. Proportion, ratios. Quickly, go ahead. Look at it. Yes.
When
Give me up. Give me page. Give me what you're looking at.
67.
60. Ooh, I was almost there. I was on 68. Go ahead. 67. 3.2.
No, number 12. So when it's all.
Okay.
When it's all number
3.2 ratio, number 12.
What is the whole number? Make it into a fraction first. Is that right?
What do they want you to do?
Convert the fraction to ratios.
Convert it to a ratio?
Yeah, so I
Yeah,
don't-
yeah. Make it a fraction, then you get the ratio. If you're going, very good point. What did she ask you to do? Because if I wanted to go right to a decimal, I would just put 1 point and then take the what? 7 divided by 8, right? Carry that out if I don't say to the nearest what? To the nearest what? Thousandths. Okay, but she wants a ratio, so you get the ratio from the fraction. So, what is it? 8 times 1? 8 plus 5? 15 to 8. Because you're going to end up with what? 15 over 8. 15 to 8. Absolutely. You should be able to take any fraction, any mixed fraction, and make it a ratio. That's a ratio. 15 is to 8, as is 1 7/8, or its decimal equivalent, for instance. Right there. This is what I was talking about. If you do these examples, trust me, she covers every way, back, forwards, up, down, right to left, circled, comes back. Really, really good. That's why I chose this book, because the other book, there aren't enough actions. There aren't enough. Can you make some up for me? I used to tell them, make them up yourself. Just throw something in there, put it together, and see what it looks like. Go through the procedure. But your author does a really, really good job. There are plenty of things. She tests you on all of it. And she does really good at the cautions and the red flags. Please. There was a red flag here that I wanted. It was a good one. I have made mention to it. I don't know if I can find it right away. Let me see if I wrote it down. Page 68, error alert. Oh, I did write it down. How about that? Yeah, sometimes I feel when I'm worse. Okay, do not forget. Here's what's going to happen. Numbers by themselves don't mean anything. Make certain that when you begin after this week, you have to put the unit of measure. And I don't like unit of measure because units is a measure. But the medical measure, that's what I make sure that numbers will start to begin to have medical measures subsequent to them. Because numbers by themselves mean nothing. 15 to 8 what? Okay, what are we comparing? Remember, we're ratioing something. We're looking at one thing to another, and it has to be consistent. Okay? Good. Anything else? Very good. Thank you. That's good. Yes. You've got 5 minutes, and then I'm rolling on and introduce you to metrics. Then we get into real medicine, not this arithmetic stuff. Come on. Oh, sorry, ladies. I don't know. I think I brushed my hair.
Page 61, number 32.
61. Everybody go over. 22. Now, 32. Okay, what is the instructions?
You have to convert it percent to fraction and reduce it. I tried to do it and I had some.
Okay, 1.2 percent. First of all, it's got a 1 in it, so it's going to be big. It's going to be a big percent. That's it. That's the percent. Okay, so what is it? 5 times 1 is
5.
and 2, 7. 7/5 is what? 1 and 2/5, right? What is 2/5? Huh?
1.4.
2 divided by 5 is what? Now I want us to understand how we got it.
4. Or 2.
Please tell me what 2 divided by 5 is. 0.
No, 1.4.
1.4.
That's it.
Does it go any further? That's it.
No.
Okay. 1, 2. It's 140%. Remember what I told you. When your mixed fraction has a whole number, it's greater than 100. It's greater than 100, isn't it? 1 and something else. So what do? Take it, make it, convert it into a what? Decimal, then get its... Did we not practice that?
No, sir.
We practiced...
It's a percent to fraction and after that you reduce it. Not, we don't have it, you put it now in.
Okay, so then we want to go back. It's 140%.
No, we have it originally
1 and.
and 2 over 5.
That's right.
percent.
That's right.
At the beginning.
Absolutely. 1 and. Okay? 1 and. Anytime you have a mixed fraction, it's over 100%. Okay? So it's 140%. Now, if you want it, now you got to take that back to a decimal? Is that what you want to do? Okay, so percent will then go to percent to fraction. Or I go to percent, decimal, and the fraction because you can get its fraction equivalent.
So you mean my fraction would be 1.40 over 100?
No.
Yes. Okay, so 1, 2. You come back here. You got 1, 2. You got 1.4, right? Okay. Now you want to make that a fraction? So it's 1 and 400ths?
It's 14 over 10. And then multiply by 100, right?
14 over 10?
Right. No, 100.
100.
That's the answer,
14
14 over
over 100?
Why don't you give them the problem so we can look at it?
Divide by 10.
What problem is it? 32. Page 61, page number 32.
Okay.
That'll make it more understandable for you. That's a good problem. I know what it is.
Is it 1.40 or 1.40?
What's the answer say?
7 over 500 is the answer.
That's your answer? Okay. Then I got 7 over 5.
3.1.
That's
And-
percentage. That's percentage.
That's percent.
I think the divided
And then-
after that by 100.
We'll take to the ratio.
Okay. 2/5. Where are we? 1, 2, here. We know that this is 14. 14 over...
No,
Because
so
it's
what
actually
it is,
1.4.
It's because.
14 over, wherever. 14 over,
No, 7.
It was
I'm sorry, I gotta go back. We're going 14 over 5 times 100,
Yes.
okay? Boom, correct? That's what we're saying. 14 over 5 times 100.
That's correct.
7
Like,
over 5.
percent is divided by 100.
5. So that means times percent, that will turn to,
That's how you get your 500.
Yeah, it's divided by
that's the
100 is a
answer.
percent.
Let me, I'll tell you what, I don't have a problem like that. Let me take a look. No. This one I need to go take a look at. Let me, because right now I had something else on my mind in here. I don't know this at this moment in terms of being able to rationalize. I want to do the steps and show you how to get that. So give me a moment. As a matter of fact, when you take the quiz, I'll have it figured out. Good. Don't have that. See, what happens is, you've got 7, you have a number that's greater. You've got 17, you've got, what, 5 times, what is it, 5/8? What is the number? You've got 7/5. That's what it is. You've got 7/5. 7/5 percent. That is a number that is greater. So you've got at least 100. You've got at least 100. You've got greater percent. You got to understand that. You're greater than that. I'll get to it. Yeah.
Example 3 is actually one similar to that, if you want to look at it. I think the answer's wrong. Example 3, it shows how you.
That's it. Okay, so we're going back. Now, that one is to get to there. This is of a percent. I'll fix that. Let me take it, because this is that of a percent. Okay, all right, good. That particular one I'll have for you in here to get back to the answer. Okay. Great, good. And it's probably, I know I've got it right, 14 over 5 times 100%. It's either, I either divide or I multiply. I can't go wrong. So I'll figure out where to go from 14 to 5. No, it's not 4. It's 7 to 5. That's what the problem is. Gotcha. It's 7 to 5 times 100%.
Right, that's what
Times
I
100.
thought. But
Times
I don't
100.
understand why is this, then the answer is 7 over 500.
That's correct. 7 over 5, and then it's divided in.
You can't just multiply by the
Okay.
denominator.
Okay. I'll figure it out. I'll have it figured out.
If it was 1.4%, would you put that over 100 and then just move the
And then
decimal?
move the decimal point. I'm trying to figure it out in terms of fraction and decimal points, and I will have it. Trust me. It'll just take me 5 minutes with y'all being quiet. That's all. Actually, 2 minutes. Okay, let's go. Metrics. Up. That's dead in the water. That's dead in the water. Okay? I will have that. It's just a matter of which way I want to move the decimal and then make sure that the fraction is the same, and I will template that for you. Very good. Thank you. Absolutely. Okay. We start looking at these decimals because in metric, medicine is housed within a metric system. It's worldwide. I want to say international because there's international units. Okay? Worldwide, we use the metric system. In the metric system, you have to command, okay, your understanding of the use of decimals and moving. What I'm going to do, the book is going to give you a lot of units. I'm going to give you the basic units, the foundational units that you're to use. Okay? You can go on ahead. You can go on ahead and practice all of the little in between. That's up to you. I'm going to test you on these basic fundamental metric units. Okay? And then we'll introduce household. Okay? GTTs, drops, teaspoons, tablespoons, being aware that if you misabbreviate, okay, teaspoons, tablespoons can be can cause some problems. Okay, I'm going to give you a hierarchy. In the metric, in dealing with mass, weight, that determines the strength, how much of a product, of drug is contained in a tablet, how much of a drug is contained in a solution, in an IV bag, etc. That is in grams. Grams. Okay? Its abbreviation equivalent is that. It centers around grams. The largest commonly used metric measure for weight is kilograms, which is 1,000 times bigger in relative value than a gram. The next touching unit to grams is milligrams, which is 1,000 smaller than gram. Gram is the center piece. And from there we go up, larger. Now, it takes less of a kilogram in respect to a gram. Even though kilogram is a larger unit. You're going to have to play around with that. 1,000 grams is equivalent to 1 kilogram. Takes 1,000 of these. That means these are smaller. If this were a box, it would take 1,000, and then we could call that a what? Kilogram. Do we understand? Geometrically, and then in terms of just plain arithmetic. This here is a milligram. It takes 1,000 of these to make up a gram. Between these touching units, there's 1,000. If you were going from here to here, how many times would you move the decimal point?
6.
From this one to this one, touching units. 3. You were going all the way from here to here? 6. Now, what difference is that? That's 1,000,000 times difference to go from here to here. Well, what do you mean? 1 and how many zeros? 1, 2, 3. 1, 2, 3. So what is it? Right? 1,000,000 times difference between a kilogram and a milligram. Now, the smallest unit, the smallest degree of relative value in the metric weights is a what? Microgram. MCQ. And so each one of these that are next door to each other are called touching units, and there is 1,000 times difference. You will move the decimal point 3 times, one to one way. It's just a matter if you're going from micrograms to milligrams, the number has to get smaller, so as you go up, you move the decimal point from where to where? From right to left, making the number smaller. Smaller. Because you're going to a larger relative value, so it will be less in comparison to the size of the smaller one. Okay, I need you, so we'll have plenty of practice of that. This is it. What I expect you to do, if you're not sure, first thing you do on your quiz or your test, do that. Set it there. And you don't have to guess. And then when you get conversions, okay, something's in grams and you need to convert to milligrams. Well, the order might be in grams, but the medication is milligrams per milliliter. So you're going to have to convert from grams to milligrams. As we go down, we move from left to right, making the number bigger. So please, mark this down. Right to left. 3 times between touching units. Okay? Over here, you're moving the decimal point where? From right to left. I'm sorry, hold on. This is going from left to right. the number gets bigger. This is going from right to left. Okay? You will move the decimal point when going from a smaller relative value, from going from milligrams to grams. You'll move the decimal point from right to left. The number has to get smaller as you go from the smaller unit to the bigger relative value unit. You're going down in between from kgs to grams, from grams to milligrams, or from milligrams to micrograms. You will move from left to right, making the number get bigger. Well, how does it get bigger if I'm going to a smaller unit? Because it will take more of the smaller units to make up the bigger unit that you just came from. Okay? That is probably the most complex dynamic in dealing with that. And have anyone, you will be tested on the use of all of these, because somewhere through there, through medication, dosage, you'll have to deal with micrograms. You'll have to deal with milligrams. In the liquid, liters, capital L, and milliliters, small m, capital L. What's the times difference between the two? 1,000. 1 liter is equal to 1,000 milliliters. 1,000 milliliters is equivalent to... Good. All right. Close your books. Practice look at just those two. Look at kilograms and milliliters. We'll deal with other units, medical units, later. In the lab, that's when we'll start, and then I will complete the lecture next week. Put it there. Come on, close it up, come over here, and here. You make sure everybody has one of these, please. Come on, my dear. I gotta make sure, hold on, I gotta make sure the answer's in this one. Somebody be done got the answers, looking at me like, oh boy, I wonder how I should handle this. I wonder how I should handle it. Baby girl, would you please fill into one of these over there by yourself? You weren't late today, were you? Not really?
No.
Okay. Just everybody. I walked in here a quarter of them, they're like, come on. Come there, vente, por favor. Come here. Okay? Now, you and I, we're going to be neighbors. I'm going to give a row one. You next to me, you going to give a row. Then we'll slide to the left. And then, I give one row one, you give row. And we'll slide